In this video, we'll compare two major deep learning frameworks widely used in the field of artificial intelligence, TensorFlow and PyTorch, and explore how to build neural networks using Keras. First, let's introduce TensorFlow. TensorFlow is an open-source deep learning framework developed by Google. This framework includes the high-level deep learning library Keras, which makes it easy to build and use deep learning models. Since TensorFlow 2.0, released in 2019, Keras has been integrated as tf.keras. Additionally, TensorFlow stands out for its scalability and deployment capabilities, supporting mobile, web, and cloud environments, which makes it a great advantage for running deep learning models across various platforms. Now, let's take a look at PyTorch. PyTorch is an open-source deep learning framework developed by Facebook, now known as Meta. One of the main features of PyTorch is that it is based on dynamic computation graph, allowing operations to be executed immediately and making it easy to modify model structures intuitively. This makes debugging simpler and is well suited for research and experimentation. Additionally, PyTorch supports GPU acceleration and utilizes CUDA technology to maximize the performance of NVIDIA GPUs, resulting in faster computation. These days, many cutting-edge AI models, such as Hugging Face transformers, are being developed with PyTorch, which is why this framework is becoming increasingly popular. Now let's take a look at how to build neural networks in Keras. Keras is a high-level deep learning framework that offers various model creation APIs to make it easy to build neural networks. Here, API refers to an interface that provides specific functions. There are several ways to build neural networks in Keras. The sequential API is a way of stacking layers step by step, and it can be implemented in two ways, using the add function or with a list. Another method is the functional API, which allows you to build more complex and flexible neural network structures. This table summarizes the features and code styles of each method. Let's first take a look at the add function method of the sequential API in Keras. The sequential API is a way to stack layers step by step. You start by defining the model with sequential, and then use the add function to add each layer in order. For example, the diagram below shows a simple neural network consisting of an input layer, a hidden layer, and an output layer. The input layer takes 3 input values. The hidden layer has 4 nodes, and the output layer has 2 output values. To implement this with the add function method, you first import the Keras library and then use add to create the input layer named input, the hidden layer named hidden one, and the output layer named output. Here, the number 3 represents the number of input values, 4 represents the number of nodes in the hidden layer, and 2 represents the number of output values. This is how you can easily construct a simple neural network. Next, let's introduce the list method of the sequential API. The list method involves defining the model by passing each layer as a list all at once. This makes the code more concise and improves readability. Let's try implementing a simple neural network with an input layer, hidden layer, and output layer, just like we saw in the previous slide, but using the list method. First, we import the Keras library, and then we group all the layers into a list and pass it to sequential in one go. Here, the numbers represent 3 input values for the input layer, 4 nodes for the hidden layer, and 2 output values for the output layer. Compared to the add function method we looked at earlier, the list method makes the code cleaner and allows for more efficient management of the model. Finally, let's take a look at Keras's functional API. The functional API allows you to clearly define the input and output of the model and connect layers flexibly, making it very useful for creating complex neural network structures. This time, Let's try implementing a simple neural network with an input layer, a hidden layer, and an output layer, just like the one shown in the previous slide, but using the functional API method. First, we import the Keras library, and then define the input layer and store it in the inputs variable. Next, we define the hidden layer using the dense layer and store it in the x variable. Finally, we define the output layer using dense again and store it in the outputs variable. After storing the input, hidden, and output layers in their respective variables, we define the model. Here, the number 3 represents the number of input values, 4 represents the number of nodes in the hidden layer, and 2 represents the number of output values. The functional API method is great for designing complex structures because it allows you to clearly define and connect each layer.